Good morning, everyone. So, for today's discussion, I will be discussing the data cleaning. So, this is very important when we do statistical analysis because if your data is not well organized, there will be a problem when you run it to statistical software. So, for data cleaning, I will be showing a data encoded to the Excel, but it is not well arranged. So, this one is an example of encoded data. This is a wrong way of encoding the data because um, we have here the first row, the second row, and the third row is utilized with the column heading, which is not good when you run it through statistical software. In managing your data, make sure that the first row is the only uh, column heading and make sure that um, there is no merge cells because if you do the merging of cells, the statistical software will not read your output. So this one, you need to delete this part and also this part. And um, here, the third column should be left. So the first and second column, you need to delete it. And this one is the respondent number, so you can write it. And this one is the student pseudonym because it is not allowed to take the student's name and their age. And then here is the scores, addition, score, subtraction, score, multiplication, interpretation. So the proper way of encoding this data is like this. So if we look at the previous one, we have deleted the first and second row. So here, the only remain is the column heading for each data. So this one, this is the right way to uh, this is the right way to encode the data, which is ready for statistical analysis. And here we have I added another column to indicate that the next data are for pretest. So if we look at the first encoded data, the pretest is in the first row. But here I insert another column which will indicate us that the following data is for the pretest. So you can have another column. Just make sure that the column heading is in the first row of your encoded data. So this one also is a wrong data. What makes this wrong is because there is a summarize of statistical summary summarized here at the bottom of the data. When you run this one in statistical software, the statistical software will also read this one and it will create error once you import this data to your statistical software. So this is check that the first row will have the column heading, but this one is wrong because there are statistical software, I mean descriptive statistics at the bottom of the data. So all you need to do is to highlight this one and delete the summarized descriptive statistics at the bottom. So here is the correct way in encoding the data. You see the first column has a column heading, and then the bottom of your data is clean. So this one is correct, and you can run this one to the statistical software. We have also here um, a data that utilizes the first column as the header of the data. So this one is wrong. For this data, this is classified as Generation X, and this data is classified to millennials. Now, if you encode like this in statistical software, the statistical software cannot read this one. So make sure that the column heading, this one, should be in the first row. So how do we do that? It is represented here. So you have your generation one. So meaning, since we have two generation here, the Gen X and the millennial. So we assume that Gen X is the one and then millennial is the two. So we have your generation and then the age group and then the sex and then the civil status and then the variables. So you see, this is what we call as raw data. The generation, the column heading is in the first row. So this is a environmental science data where they have a merged cells for the first row, and they title this one as the total number of individuals because this data corresponds to the total of individuals in, for example, this one. Um, the total individuals in Barangay Igan, Quadrant 1, in the downstream is 14. So we have how many variables here? We have the total number of individuals, the type of streams, the barangay, and then the quadrant. So we have one, two, three, four. So the first four columns should be these variables. And then this is how you will encode this one. So we have the barangay, the quadrant, the number, the individual, and this is how you will encode you the variables barangay should be in one column, the quadrants should be in one column, but you need to encode it based on the quadrant and then the number of individuals. Here is this is how you will I use the formula here because they were computing the Shannon index before you will uh, run it to statistical software, their formula. This is for the environmental science. We have here also the um, this one is for um I think my client here are uh they are a nutritionist and they want to have a bioplastics. So they want to compare it to commercialized plastic. This one is their raw data and the variables they are interested in is the tensile strength, the maximum supported load, the thickness and the width and the length of the bioplastic samples. Now, this one is wrong in encoding because they are doing the table. They have doing the table here, and this is not the right way to encode the data. So again, your data should have the column heading from the first row. So here, this is wrong. And the right way to encode this one is you will have this one. You have the treatment. The treatment here are this one. We have the T1, T2, 3, 4, 5. And here they are doing the proper way to encode it is you need to have the treatment one, the treatment in one column, and then the potato starch, how much it is, and the water, the glycerin, the seaweed, and the eggshells, the trial, and how many, and the degradability. So the point here is this encoded one is wrong. The right one is it the row head, the first row should be your column heading. We will have an example later. So exercise. We have here an experimental and we are talking about the height of the plant. Now for the height of the plant, um, this is very easy in encoding. You just identify the variables or the column heading that we should have. Here we have the height of the plant as the dependent variable. That is one. And then we have the trial, one, two, three. We have three trials and how many treatment? We do have four treatment. The TO here corresponds to the control treatment, which is the commercialized one. So in encoding this one, make sure that you will be accounting everything, every variables. So we have the treatment as the first one, and we have the trial and also the height of the plant. So um, this is uh, in order to in order to compute how many data do we have, all you need to do is just to count the number of treatments. One, two, three, four. We do have four treatments and one, two, three trials. So three times four, we do have 12 data. Um, You can count also here that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 data for the height of the plant. So we will be expecting that we will be encoding up to the 13 because the first one is the column heading. And then here is the, um, since we have 12 data, we will end the data up to the 13. So if your data will be more than 13 or less than 13, so the way you encode it, there is something wrong with the way how you encoded it. So since we have um, uh, control treatment and it has three trials, so we do have three control treatments and we do have three T1 and three T2 and three T3. So if we see here, we have um, three treatments for the control treatments and T1, three also, and T2 also three, and T3 is also three. Now for the trial, we just need to put 1, 2, and 3, 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. So it means that when we look at treatment O or the control treatment and then the trial one, we have a data of 57. So that's 57. And we have treatment 0 and then trial 1, treatment, control treatment, and then trial 2, we have 54. And then treatment 0, trial 3, we have 55. So the easiest way here is just to um, copy and paste it. You need to use the transposed one. So the pattern here is you will start from the left to the right. So you just copy the 42, the 39.23, the 41, the 43, the 44, 41, and then 50, and 55, and 54. So that's it. You have, and this one is ready for a statistical analysis. So another problem set is, so this is the proper way to encode it. Let me maximize this one. And then we also have here the exercise 2, a two-factor with 3 replication. The interested variable here or the dependent variable is the number of leaves. Now, this is how you will compute how many data are we having here. So we have here that this treatment has been replicated 3 times. So you have 3. And then how many treatments are there? So we have the first factor is the planting distance, which is represented by planting distance is represented by 20 centimeter, 30 centimeter, and 40 centimeter. And then there is a variation for treatments. We also have here 4 treatments and TO, which stands for the control treatments. And then within the 2 factors, there is also uh, there are 3 samples in each combination of factors. So we have here 1, 2, 3. That's 3. And then 3 times 1, 2, 3 for the planting distance. That's 6. And then we have how many treatments here? 1, 2, 3, 4. 4 treatments. And then for each treatment or for each factor, we have 3 samples. So we have 6 times 4, we have 24. And then you also multiply here the how many samples you have taken for the combination of the factors. So you have 6 times 4, 24 times 3, 24 times 3 is that 2 carries 3, carry 1. You have like, wait a minute. Let me do the calculator first. But I think it is, I do have a, um, I do have a um, answer key. So this one is the answer key. We have 108 samples. So if we calculate it, let's calculate it first. I'm using a calculator here. So we have 3 trials times 3 planting distance. That's 9. I'm sorry. I said 6 earlier, but that's 9. And then we have 4 treatments. So that's 4 times 3 samples in each factors. So we have 108 data. Now the data here, the 108 data is if you need to add 1 because the first row row represent the column heading. So this is it. You have this one has 108 data because um, we have 3 replication with um, 3 planting distance, and then we have 4 treatments, and for each combination of factor we do have 3 samples. So you have 108 data. So this is how you will encode again the principle or the way you will encode your data. Only a simple one. Just make sure that your column heading is in the first row, and then the rest should have the row data. So let's check this one. If we do check here, trial 1, this is trial wall or replication 1, and then treatment 0, this one treatment 0, and then we have planting distance 20, planting distance 20, and then data is 20. The number of leaves is 20. Next is still trial 1 or replication 1, and then treatment 0, and then we have the planting distance 30, and then the number of leaves is 18 here. And then we have still trial 1 and treatment 0. We have planting distance 40, so we have 19. So we have 2, 20, 30, 40, 20, 30, 40. So we are using for the planting distance. And the number of leaves, you just copy and paste it from the left to the right. So if you are having trouble, you can just pause this video and look at the pattern on how I copy pasted the number of leaves. So that's all for the video today. So don't forget to like and subscribe. Thank you.